All right, let's figure out if it's 24 volt, 12 volt, or 48 volt you need for your solar system. That is always the question, and let me show you how to figure it out. So let's start with a very simple example. We're going to start with a standard, assuming that most of you need to run power through a standard wall outlet. That means that you're probably going to want at least one wall outlet. So I'm going to do everything based on one wall outlet, an example, so that you understand how to calculate what you need to know. So let's assume, first of all, that we have, let me grab the right color here, we have 120 volts, and you need a 15 amp standard wall plug. Now, a 15 amp standard wall plug, what I mean by this is that in a house, when you plug something in a 110, 120 wall plug, that is what it typically would be, is a standard 110 wall plug. Now, at 15 amps, you're going to want to pull 1800 watts. Now, as we know, watts is volts, or watts divided by volts equals your amps. So that is where 15 amps comes from, and that makes your calculation going forward, watts divided by volts equals amps. That will become significantly important later when we talk about wires, what kind of wires you'd want, what kind of wires you think you might need, and why the cost difference is, and that'll help you decide what you want to do here. All right, so let's take this to the next phase, and let's talk about a 48 volt system. Now, with a 48 volt system, you want the same amount of power, 1800 watts, but in it, you're going to need 38.5 amps. And with a 24 volt system, you want the same amount of power, but you're going to need to pull 75 amps. And with a 12 volt system, you need to pull 150 amps. These numbers become very significant later when we start looking at batteries and we start looking at cables and wires. So you need to decide where your usage is and what your usage is. And if you need to figure out how to calculate usage, then there's lots of good ways to do that, and I will point you to another video or create you one if it's necessary. Write me down at the bottom if you have problems with that calculation, and I'll let you know how to do it. All right, so at a 38 volt, at 38 amps, each one of these is going to be able to provide the 1800 watts. So this needs to go through an inverter. The inverter would in turn take your 1800 watts of whatever voltage you happen to provide and translate that into the 120. So we will just draw that up here as the power comes from these, goes into the inverter, and comes out on this side as the 120 15 amp 1800 watt wall plug that you're looking for. Now, there will be some, I am not accounting here for what the inverter cost is. And what I mean by the inverter cost is, in order to convert that power, there is a cost. To run this piece of equipment doesn't cost nothing. So we will have to figure out what that cost is and add it on to that wattage and then recalculate your amps. But for argument's sake and for simple calculations to determine what you're looking for, it's much simpler just to work with some clean math, and let's just go through the process for one simple wall outlet. Then you can determine how many wall outlets you need, and from how many wall outlets you're looking to get, you can determine which system you're looking for, whether that's a 12 volt, a 24 volt, a 48 volt, or a 120. Or, obviously we all want 120. Okay, now, if you are looking at the idea here is, if you're looking to run some simple lights that are in your RV, then you may want to go with the 12 volt. because chances are you're not going to need 1800 watts to run those lights. But we're talking about creating you specifically a solar system that allows you to get wall plugs that provide 1800 watts or a 15 amp standard household wall plug in it. Okay, so let's talk about what would be the equipment or the cost to doing each one of these, because this is what it comes down to, is that each one of these has an inherent cost with doing it. And why, you ask, why are people so bound and determined to use 48 volt? Well, let me explain it to you. So we're going to take the system that we have here, and we're going to break down what the wiring cost would be in order to go to the 48 volt system. On a 48 volt system, you're going to need to get a 8 AWG wire to run from your 48 volt battery to your inverter. So this is 8 AWG. Now, an 8 AUG wire is a very inexpensive wire, and you can get one of those at a much less price than you can get the other ones. So for example, let's go through the examples and then we'll come back and visit what we have for the other ones. The 24 volt system, you're going to need a minimum of a 4 AUG wire in order to run 1800 watts out of this 24 volt battery and up into the inverter in order to get to your 120 volts. And then with a 12 volt system, you're going to need to use a 1 AUG wire. I couldn't find 1 AUG on the pricing, so what I'm going to do is I'm going to go with the simple 1 aught. It's a little bit more oversized, but when you're dealing with amperage of this nature, it's usually a good idea to go one size over anyway. So this is shown as 1 aught wire, and the 1 aught wire is what is needed to support up to or over 150 amps or 1800 watts from a 12 volt battery to the inverter, and then go over to the 120 volt wall plug. So now that we've discussed what size wires, let's talk a little bit about the price of those wires, because this is where things get. If your inverter is sitting a foot away from your battery, no big deal. You don't really mind running a small wire of regardless of what size it is, 1 foot. Obviously, the smaller the wire, the safer the system. So let's look at the standard. Let's look at a standard wall outlet first. Standard wall outlet, you could go and you could buy some cheap wire at Home Depot, and you can get it for 60 cents a foot or whatnot. In the real world, you probably, in an RV or something of that nature, you probably wouldn't want to do that. And I looked up 100 feet for $66.38, which is 66 cents a foot for the marine grade wire that is much safer at 105 degrees Celsius melting point. So if you're going to be doing something of this nature to run these things, and you're going to want the really high grade. Now, for a standard wall outlet, you wouldn't need that. You could use standard wall outlet wire, but for comparison's sake, I wanted to give you the scale all the way down. So then we look at the 8 AUG wire that comes from a 48 volt system, and with the 8 AUG system, we're talking $1.79 for that same wire to run from your 48 volt system to this. Now, if you've got one battery running there, not a big deal. If you've got dozens of batteries running there, now things start to become more significantly problematic. Then we look at a 24 volt system, and on the 24 volt system, it's 4 AUG, and it's $4.90 approximately a foot. And as you can see, the price is increasing here quite dramatically. Then when you get into the 12 So at the 1/aught wire, the closest thing I could find, like I said, was 1/aught as opposed to 1 og, which technically you only need 1 og. I would probably go with 1/aught anyway, and I did in my 48-volt system, but that's another story. So in this one, it is $15 for each foot of this wire. So as you can see, a lot of the amperage that you need to carry in each of these systems for a simple wall plug can cost you a tremendous amount of money. And if you need it more than that, then it gets to where you're going to have to run 2 of those wires, 3 of those wires. And of course, if one of those wires has a problem, then your system doesn't have enough wire to support the amperage that's there, and you end up with lots of cascading problems. So when you get an excessive amount of pull for these. Now, if you're running a couple of lights and that's about it, and maybe a TV and a little RV, and it's not a big deal, and you don't really need 1800 watts, you're running a little 300-watt inverter and some 12-volt light bulbs, that's different. Because that, you might want to get away with a 12-volt because it would have come standard in your system already. It'd be very easy to do it. Now, let's talk about the next phase of this. Because the next phase of this is going to be, what is the impact on the charge controller in order to charge your battery? Because we've talked about getting the power out of your battery and getting it into the inverter and getting it up to the 120 outlet. But now we need to talk about, what does it take to get the power, it's what we call a charge controller, and to take the PV from solar panels and put them into these batteries. Now, a lot of this part of it depends on how many solar panels you have and all that. But let's look at the charge controller in particular. That is where the significant cost difference between these can be had. All right, so let's talk about charge controllers. Now, I'm going to give you an example charge controller here so that we have something to work with. I have a Victron 150/35. Now, that means that it can input 150 volts and output 35 amps. Now, 35 amps output is based on the battery that it is going to. So, 35 amps, obviously here, 15 amps is 1800 watts, and 15 amps here is a whole lot more. So, let's do the math on what this means the maximum charge rate for each one of these batteries could be. And let's just assume that you have 400-watt panels that we've listed down here. So we're going to list these as 4, and they're each going to be 100 watts. Just like this. And we're going to take these 400-watt panels, and I got to make sure I have my calculator here because this is going to be some sloppy math as we go along. These 100-watt panels, if they're going to let's assume that it comes in to the charge controller and then goes over to the 12-volt battery. The 12-volt battery, we can have a maximum of going out of 35 amps. So at 35 amps times 12 volts is 420 watts. That means that these 400 watts that we have for these panels, if we added one more, we would have more, and then it could go into the battery. So these 400 could go in there. Now, so that means this one, we can do 420 as a maximum. And at the 24 volt, that doubles to 840 watts. And at the 48 volt, that doubles again from the 24 volt to 1680 watts. Now, this means that this is the maximum that it can pump in at one time. You're not going to get 400 watts out of these at each time. So typically what you're going to do, you're going to have to judge the number of panels that you need. I'm not going to do this calculation today on how many panels you need and everything. This is more about which voltage of which system that you want. But you need to be very much aware of the fact that if you want 1500 watts of charging power and you've got a 12 volt system, that means that you're going to need to easily have 3 or 4 of these charge controllers, and this one ranges around $165 at the time that I made this video. Now, that means that you're going to have a good $400, $500 in charge controller power money tied up just to charge your 12 volt batteries. And then you also have got to consider that when you have 1500 watts going into that 1200 battery, you got to look at the maximum amount of amperage. 1500 divided by 12 is 125 amps going into this battery, and you need to be very careful that you look at the battery's maximum charge rate, because chances are one battery would not do that. Would mean that you're going to need multiple batteries, you're going to need to add bus bars to your system, you're going to need to have more cable, more expenses, and so on and so forth. Whereas you go back to the same system at a 24 volt, now you can pump in twice the amount, and all you need is 2 charge controllers at this price. And if you go to 48 volt, the same charge controller, and you need 1, because 1 is enough to get all of that wattage in at the same time. As a matter of fact, you could add in another whole set of them and get that in also. So it depends on how many panels you're going to have and how much power you want to put in to these batteries, how much you want to spend on your charge controller, how much you want to pull out in how much power you need to provide. Hopefully, though, this gives you the basics to understand the key elements that is needed to determine what you need to get a 12 volt, a 24 volt, or a 48 volt system. With all of this information, you should be able to make that determination. If you can't, and you have a question, or I wasn't clear about something, please feel free to write me, let me know, write down in the comments right below. I will be glad to answer your question, and we will make sure we get you a full answer and get you taken care of. And if you haven't already, smash that subscribe button right now. Make sure you come back for more videos. Make sure you go to one of my playlists and watch everything that we've got out there. And if you haven't seen my solar shed yet, check that out. I've got an RV. My solar shed supplements my power so I can be completely and totally off grid. I encourage you to go out and watch it. Thanks again. Like and subscribe. We'll see you on the next video.